بس احنا شفنا يمكن هذا يعني الداتا شو على العرض افضل، فاحنا تبقى اللابتوبات والموبايلات يعني احتياط، اخاف تصير عندنا اي مشكله نستخدمهم. بس حاليا حيكون آه، على هذا البرنامج داتا شو حتكون ترجمه فوريه موجوده، وصار الاتفاق بين كل المداخلات لحضراتكم، يعني اي مداخله اي تعليق المحاضرات حتكون داخل القاعه هنا باللغه العربيه، وهم يكونون باللغه الانجليزيه. اكيد يعني عندنا مواضيع يعني الكمامات والسلام، وهاي ان شاء الله حتى الكل يكون ملتزم بها، لان هذا من الشروط اللي اتفقنا وياهم حتى ننظم الورشه. الاجنده يمكن وصلت لحضراتكم من خلال الايميل، وان شاء الله يعني كل شيء يمشي على الاجنده، ما عندنا شيء، بس يعني التفصيل البسيط يعني احنا اللابتوبات والموبايلات نخليها للاحتياط يعني.
Good morning, everyone. Okay, so you can see me. I hope you hear the Arabic translation. Yes, you can hear the translation on your side.
Yes.
Excellent.
Yes, I hear you.
Very good. Okay, so let me say good morning to everybody. I see that a number of us are already signed on. And we will, I think we're still waiting for one of our experts to join. Chi, let me ask you to just reach out to Mike just to make sure that he doesn't have a problem signing in.
I will. I sent the reminder this morning to everyone, but I'll do that again.
Okay. Maybe try to reach him on his phone. Okay. All right. All right. So while we're welcoming everybody, I just want to introduce myself. Good morning. My name is Marisol Estrella. I work with the UN Environment Program based here in Geneva. I work with the Resilience to Disasters and Conflicts Global Support Branch based in Geneva. And I also coordinate the partnership between UNEP and Norway's Oil for Development program, which also has a bilateral program with the government of Iraq, as some of you may know. This is also why we are here supporting you, because we have this cooperation under the Oil for Development program. And we are supporting specifically on environmental governance, environmental management issues related to the oil and gas sector in specific countries. Many of them are in Africa, but also includes Iraq as well in the Middle East. So let me now take the time while we're waiting for our other experts to join. To ask you first to introduce yourself around the room. I don't know how, I'm just trying to think how we can do it. Yeah, maybe we can just, I see the room. We're seeing the room with all of you. And I think most of you are already in the room. Mr. Ayman, you have your hand up. Do you want to say something?
اوكي.
Yeah.
صباح الخير.
صباح الخير يا فندم. أنا معاكم أيمن عزائي.
Marisol, you can hear me? Marisol?
Yes, okay. I can hear you now.
Yeah, okay.
Okay.
Okay, in the meeting we will speak in Arabic language, okay?
Okay,
Yeah.
So that's fine. Thank you. Yeah. Your camera and sound is working. Okay, thank you, Mr. Ayman.
السيد أيمن، شكرا لك.
We're waiting for a few people to join.
Yeah.
Let me ask people in the room to introduce themselves. Okay. So, how are we going to do it?
اوكي. اوكي. شكرا مارسول. طبعا
Good morning, Mr. Yusuf.
بالبدايه
Marisol, at the outset, we'd like to thank the Ministry of Environment and the Ministry of Transport to the Oil for Development Program for the task that we have been working for 2 months. Marisol, for us, can you hear me? He's asking. We extend our thanks to the Secretariat in Basel and Rotterdam, and because there are international experts and the regional office in Cairo who are with us today, and I will be in the hall to facilitate issues, and we now introduce the participants.
كل عربي هنا.
So we'll just go around.
لنبدأ حول sorry.
Yeah.
Can I? Okay. No, it's just we're having the translators in our headsets. Let me just go by table, and then if you
السلام
use the
عليكم.
microphone.
سعد عبد العزيز حسين، مهندس كيميائي.
Saad Abdelaziz Hussein, chemical engineer in the Ministry of Transport. Ali Hussein Hashim, the Ministry of Petroleum in the Operations Department. Walid Ismail Amara, Ministry of Transportation, Research and Development, Oil Research and Development. Muhannad Saifuddin Omar, engineer in the North Oil Company. Yasmin Rahim, chemist in the Ministry of Oil, of Petroleum. السلام عليكم. عبير زاهر, مصافي الوسط Company, biological head of biological engineers. Hanan Juma Ali, the digging Iraqi company. Assistant head of engineers in the chemicals department. Jassim Ali Nawar, head chemist in the technical department, Middle region. In Baghdad, I work in mid Baghdad. Head engineer in the excavation in the Ministry of Petroleum. I'm sorry, the voice is not really clear in the microphone.
Just to speak slowly so that we can get the translation. Okay? So we'll just go a bit slower. Thank you. Okay, please proceed.
مازن فائق محمود.
مازن فائق محمود. Kirkuk district assistant head engineer in the polluted locations. Mohammed Najmuddin, chemicals head in the north area. Ammar Shamil Mahjoub in the chemical department. Head chemist in the chemical.
رئيس مبرمجين حيدر أحمد.
Programmer Haider Ahmed, the Technical Assistant, Ministry of Health and Environment. Sora Basser, a chemist in the Ministry of Health and Environment. Safa Abdurrahim Majid, Programmer, South Gas. Fatma Hassan Ahmed, Basra Petroleum Company, Environment Department. Ahmed Adwan Abid, North Masafi, Environment Department. South Refineries or South Masafi in the Ministry of Petroleum. Saif Ali Abdel Hussein, Assistant Head Engineer in the Mid Petroleum Company. Mohammed Khair, Head Chemist in the Environment Department in Basra. Ghassan Kadhim, Biqar Petroleum Company, Ministry of Petroleum for Wastes. Ali Waidah Mahmoud, Head Engineer in the Ministry of Environment, dealing with the wastes. Head of Engineers in Nafat Nissan or Petroleum Nissan Company. Kadhim Hassan, Ministry of Environment, Head of the Chemicals Department. Wasam Abbas Shara, Head of the Environment. Kalthum Ali Shadid, Head of the Chemical Department. Hussam Abdul Muttalib Hashim, Assistant Engineer for Petroleum Pollution in the Ministry of Health and Environment. Hiba Muhammad, Assistant Head Engineer, Dangerous Hazardous Wastes Control. Good morning. Isra Munqid Abdel Jabbar, Ministry of Environment, Basel Coordinator. Chemist Riban Saleh in the Ministry of Health and Environment. Head Technician Coordinator in Rotary Agreement. Yusuf Maher Yusuf, Head of the Public Relations, Ministry of Environment.
Much. I just wanted to get an idea of who was in the room, and I just wanted to welcome all of you again for making the travel to Erbil from many different locations. It sounds like from Baghdad, but also from the other governorates. So I would like to thank you and welcome all of you, and I hope we will really have very fruitful discussions. It also sounds like there are many people in the room who have the background that we will be and then we will be discussing on these various topic areas on chemicals and hazardous waste, also under the Basel, Rotterdam, and Stockholm Convention. So I think we definitely have a very nice group of participants for the week. And now I will ask to our training team to introduce themselves, please. Chidima, you can please go ahead and start.
Hello, good morning, everyone. Nice to be here. My name is Chidima Zikikora, and I work with UNEP on the UNEP Oil for Development project, and I support the coordination and delivery of training. So I think you must have been receiving more emails from me. So it's nice to actually see you virtually. I hope we have a good training. Thank you.
Thank you, Chi. Bella, please go ahead. Bella, you have the floor.
Oh, good morning. Hi, I'm Bella. It's nice to meet you all, and we're looking forward to having you all here today. I'm an intern on the team. I work with Marisol and Chi on the UNEP Welfare Development Partnership team, and I'm helping with support. So looking forward to being here today.
Bella is also calling from Washington, D.C., so it's midnight, almost past midnight, her time zone. So thank you, Bella, for joining us. Let me now turn to our technical experts. Mike, please go ahead.
Hello, good morning. My name is Mike Cowing. I'm the Chief Technical Advisor to the branch, and happy to be the course lead over the next couple of days, and looking forward to a very good interaction. So again, good morning and thank you.
Thank you, Mike. Good morning. Also quite early in your side, based in the UK. Then may I call on Miss Yvonne, please?
Good morning, and thank you very much for the chance to say hello to all of the participants. My name is Yvonne Ewang. I work within the Secretariat of the Basel, Rotterdam and Stockholm Conventions. I am one of the legal officers within the Secretariat, but we also have a team of scientific, legal and technical experts who are available and more than happy to help you over the course of the next few days, but also working hand in hand with the government of Iraq as we go forwards to help you with implementing these three conventions. So I'm looking very much forward to giving you some information and presentations later on, but also to really beginning a very fruitful and hopefully a long-lasting conversation with each of you. Thank you.
Thank you very much. Mr. Ayman? And
Yes. Assalamu alaikum.
Assalamu alaikum. My name is Ayman Abdel Baki from the EGPC in Egypt, under the Ministry of Petroleum, and I have the pleasure and the honor to be with you in this training session, and I hope that we communicate and to reach the best goals for this training, and wish you all the best of luck in Iraq. Thank you.
Is Chidema, I think we have another colleague joining from Egypt.
Yes, but he's not on the call yet, but he'll join soon.
Okay. And I see there, I think there might be one participant who is also on the line. Would you like to introduce yourself, Mr. Al Mansour from the South Refineries Company? You have the floor. You have to press speak, Mr. Al Mansour, on your dashboard. Okay. Perhaps I don't know. I don't know if Mr. Al Mansour is in the room or calling in from somewhere else. Okay, thank you very much for the quick introductions, and we hope to really get to know each of you as the day and the week unfolds. We hope to have very rich discussions. I see that the room looks very comfortable. We have a podium, so we will be able to see your faces much more closely when we have group presentations and when we have group discussions. Okay, so let me now turn to Chidema to give us an overview of the week and our course objectives for this week. Please go ahead, Chi.
Marisol, can you please confirm that you see my slide?
Not yet. I see. Oh, now we can. Yep, perfect.
Okay. Good morning, everyone, and welcome again to the training. Just to give a brief overview of what to expect today, and for those of you who are not familiar with the Oil for Development program and the UNEP partnership, I'll just say a few words on this. So the partnership is based on the environmental pillar of the Norway's Oil for Development program, and uh, part of the objectives is to help countries to strengthen their institutional capacities, uh, all these countries in the OFD program. And we do this in partnership with some of the Norwegian colleagues, and this to help countries to reduce their environmental risk, including oil spills, chemicals and waste management, which we're doing today, and also to increase the accessibility and dissemination of trainings on environmental management in the oil and gas sector. So Iraq is part of the OFD program, and that's why we're delivering this training today. So, main services under this partnership include direct technical assistance, some of which we've also rendered to Iraq in the past on contaminated sites assessment and remediation. We also deliver like in-country help countries to do their institutional capacity needs assessment, which I will speak in a few minutes. And we also deliver national, regional level trainings and also build a community of practice and global outreach. One of the technical assistance we have rendered is to Myanmar, to the government of Myanmar, and we have also done this for the government of Iraq, like I mentioned earlier, on the remediation of contaminated sites assessment. I think we did this in 2018 or 2019. So we also help countries to identify and prioritize their needs uh, to strengthen their environmental management in the oil and gas sector. And we also help the government of Iraq in identifying these capacity needs and did the assessments with them. We also have done this for the government of Uganda and for Mozambique. So over the course of this partnership, we've developed different trainings, including the foundation course, which Iraq has also been part of. We have also developed chemicals and waste management, which we delivered for the government of Iraq in Lebanon in 2019, and also contaminated sites assessments and remediation, environmental sensitive areas training, and trainings on air emissions and climate change issues, oil spill decommissioning, which is a new training, produce water management, which is also a new course, and associated gas treatment and process. Um, so For we have delivered a number of trainings under this partnership to the government of Iraq, including the foundation course, which we've delivered twice. One time together with the government of Lebanon, and the other time on by request from the government of Iraq. We also have delivered oil contaminated sites assessment training in September 2018, chemicals and waste management training in June 2019. We delivered last year the gas treatment and processing uh, seminar. We also Iraq has also been part of the regional training on operationalizing national oil spill contingency plans, which was delivered in May 2019. And finally, we also helped to deliver training on remediation of oil contaminated sites in September 2019. The partnership began in 2016, but from 2017 to currently, we have developed 11 thematic training courses, which I just mentioned briefly. We have delivered over 20 national trainings, uh, I think like five to the government of Iraq and 10 multi-country trainings. We have also trained over 800 women and men. Uh, Targeting the national and local government officials and also civil society academia, and national EIA practitioners. So, in a bit to make this information accessible to everyone, we developed and established a global community of practice, which is virtual online, and we through this we develop every month a monthly newsletter, which some of you must have been subscribed to. We could also share the link to join the network if you're interested. So we also publish like upcoming events, publications related to environmental management in the oil and gas sector, and it's also a platform for peer-to-peer learning and networking. So on LinkedIn, our name is Global Network on Environment and Oil and Gas. So we have over 2,800 connections in LinkedIn, and you're welcome to join this network. We can also add you after the training to the network if you're on LinkedIn. We also the network also organizes webinars, part of which this year we decided to organize a global webinar series. The first one was on the 29th of April. We have one coming up on the 6th of July on available technologies that contribute to climate mitigation in the upstream oil and gas production. So this webinar will be addressing like technologies such as carbon capture and storage, and also technologies used to reduce, for example, methane emissions in the oil and gas sector. We have a third webinar which will be coming up on in October on the 19th on decommissioning of oil and gas fields, showing best practices on this. And you're welcome to register to join the webinar or share with colleagues. So today, we know that this is not new to Iraq. We've also delivered previous chemicals and waste management training before, and from the TNA, we see that you have a lot of knowledge on issues like this. So this training is going to be more like a discussion to like we would learn from each other, and we would like to invite you to ask as much questions or provide as much comments as possible. So some of the objectives of this training, which you must have received in the program agenda, include reviewing and learning about hazardous waste streams in the use of chemicals generated in the upstream oil and gas value chain. At the end of the training, you would be able to expand and deepen your knowledge of key environmental and health concerns associated with chemicals and hazardous waste management. We'll also hope that you expand your knowledge and discuss during the training the management of chemicals and hazardous waste management, the treatment and disposal options in relations to oil and gas sector. We also would learn about international frameworks, obligations and guidelines on the management of hazardous chemicals and waste associated with oil and gas exploration and production, including through the implementation of the Basel and Rotterdam Conventions in particular. We also learn about best practices in relation to chemicals and hazardous waste management in the oil and gas sector. We will draw from industry best practices and the EU frameworks and guidelines. Also, you will finally learn how to improve your data classification and management and reporting requirements for the oil and gas sector. So, how will the training be delivered? So, throughout the course of the 3-day training, we hope that you would benefit and use our experts' time as well, and very well to understand the topic and to raise issues and seek answers and a better discussion. So, we will be doing this through online presentations and Q&A. We will use case study examples, some videos. We would will have facilitated discussions, group work exercise. This would we would share the
Chidima, I just wanted to check if you're there. I think we may have lost her. Okay. It's that if we have lost Chidima, we have lost you just in case you are hearing us. Um, I'm just going to continue we're wrapping up anyway. So I mean, just to give a bit more context also to this particular training, just confirm to me that in the other side in the room, you can hear me. Can you please confirm? Because I lost a visual of you.
Hello. Hi, Marisol. Can you hear me?
Yes, I
Okay.
can hear you now.
Yes, I'm not on, I don't understand what is happening since.
Yeah,
So,
yeah.
Okay, so we can see the room now.
okay.
It's all right. Then anyway, we're wrapping up. So yeah. Okay.
Okay.
Okay, go ahead, please.
So we will have quizzes and knowledge assessments, based final knowledge assessments. Um, then an overview of the week. We would have different sessions, and we'll have group work, two group work. The first day today, we will have group work, and we will share the instructions later on how to embark on this group work. And we'll also have team reflections at the end of the day. For day two, we will have three different sessions as well, and have team reflections at the end of the day. For day three, we would have group work, and we'll also share the instructions on how to participate in the group work. So we encourage you to participate in the training as much as you can, and uh, be in the training room, because we will be taking attendance over the course of the training. So we asked you, thank you so much for completing the training needs assessments. We had all of you complete the training needs assessments, 10 people, 10 female and 29 male. And we asked if you had previously attended any training on environmental management in the oil and gas sector. And more than half of you said you had not, but 45% said they had participated in a training. So we also asked you to do a baseline knowledge assessment, and the average score was 60%, and 24 out of 39 of you actually completed this, which is a good score. And this knowledge assessments, what we would go through them during the course of the training, and it's just made up of 24 technical questions to help you understand or refresh your memory on what will be taken today in the presentations. So we also try to know your level of expertise from the training needs assessment, and we see that a lot of you have knowledge on oil and gas processes, on hazardous. A lot of you have good expertise knowledge on hazardous chemicals and waste management. We also have people who have knowledge on protection of public health and environmental quality and water resource management, especially, and also environmental issues associated with oil and gas exploration. Some of these issues will be talked about during the presentations today and throughout the course of the training. A few housekeeping rules. So if you read through the logistics note which we sent to you and the program, we require that you attend the training at least 90% of the training to be able to get your certificate. So we hope everyone will participate in the training. We ask that if you receive a call, that you go outside so as not to distract people in the room, and also you put your phone on silent if possible. If you need to speak, we ask that you raise your hand, and then we would have the mic reach you so you can ask your questions. Uh, and then everyone is on mute, so this does not apply. So we hope that you learned so much from the training today, and that you participate in the discussions that will be going on during the course of the 3-day training. So at the end of the day, we will require that you do a team reflections to identify 3 top takeaway messages from the presentations on the day, and to identify also key challenges regarding chemicals and waste management that were highlighted during the presentations of the day. And finally, that you would identify like current efforts to help address any of the challenges. So I think this is all, and I wish you all a good training. So finally, before as I wrap up, is just we don't need this actually. Okay, so that's it from me. Thank you so much, and I wish you all the best in the training.
Thank you, Chidima. Thank you very much. Let me just pause here, and maybe there are some questions from the floor about the training itself before I continue. So let me just pause and ask people in the room if you have any questions or any thoughts that you have in your minds before we start. Okay. I don't have visual of the room, so I assume that there is no one who has a question. Can I just get Can I just have somebody verify?
You don't see the room?
Not from my side.
Oh,
It could be internet. Okay, that's
yeah.
fine.
Okay.
Okay, so as long as there is no questions from the floor, I just wanted to just take a step back. Chidima presented on the course objectives, which you have in the training program. We've had a number of meetings, in fact, with a number of colleagues from the Ministry of Health and Environment and Ministry of Oil about how to put together this training program. So we hope that we will be able to cover some of the major issues that you are facing with regards to the waste, legacy waste issues, and current waste issues that you are dealing with in the oil and gas sector. And there was specific requests to find out more how to manage these wastes and report on these wastes under the Basel Convention, which is why we have invited a number of colleagues working under the BRS conventions to be able to be with us for the next 3 days, so that they can also respond to some of your questions. And then, as you have seen from the training program, you have the profile of our training experts. Mike Howing has worked in the oil and gas sector for over 20 decades, not 20 decades, 20 years. You're not that old, Mike. So he's worked in the oil and gas sector and has a lot of experience. He's in fact our chief technical officer in Nigeria, leading the cleanup efforts in Ogoniland there. So you can also he will also be able to respond to many of your questions related to chemicals and hazardous wastes. Okay, so it's raining quite hard on my side, so I hope it's not disturbing the sound quality. Um, another point that I wanted to add is that UNEP is in fact very much supporting Iraq as well in the methane emissions reduction work in the oil and gas sector in Iraq. We started providing trainings and awareness raising on air emissions and climate change issues, and specifically on methane emissions reduction, which I'm happy to say is now recognized in your updated NDC, National Determined Contributions draft document, which has been sent for approval internally. So we're very happy to hear about that. So we are also working on a number of issues in Iraq related to emissions, and also supporting the Ministry of Health and Environment on establishing an EIA data repository platform to allow the EIA process, the environmental impact assessment process for oil and gas projects, especially, to be more efficient within the Ministry of Health and Environment. So those are also some of the work streams that are ongoing in Iraq right now under the cooperation we have with Oil for Development. Okay. So are there, I just want to pause again if there are any further questions from the floor. how are things? How are things there? Are things comfortable? The room is comfortable. You're well set up in your rooms. I just wanted to get some confirmation from how you are feeling from that side. Wow, I'm very big. I'm sorry, I'm so big in your in your screen. Hi, Mr. Youssef.
اوكي. شكرا مارسول. الامور اللوجستيه تمام، يعني ما في اي مشكله.
Thank you, Marisol, for logistics. Everything is fine. The voice and image is fine, and the presentation was clear, and so we don't have any questions so far.
Okay, now let me turn back to the room. If we can ask our video cameraman to turn back to the room. I just want to see your hands raised if you were able to watch the introductory video that we shared, the link that was shared in the logistics note for you to watch before this training. So how many of you watched the introductory video? Did anyone watch? No? Okay. Yeah, I see is somebody's hand is up? There's one person's hand up or a few? I can't see very clearly, Mr. Youssef. There are a number of people who watched the introductory video.
تسع اشخاص.
9 persons. 9 persons. Yeah.
So what I know it's in English. So for those of you who can follow the English video, I would encourage you to watch it this evening. Because it will also give you a bit of more basic knowledge about chemicals and hazardous waste issues related to the upstream oil and gas sector. Because we will not elaborate significantly on hazardous chemicals and waste issues within the oil and gas sector per se, because we have already given this training previously. And so we will only give an introductory discussion now. Mike, I will ask Mike to give his presentation. It will be very quick, very short. And if there's some things that you want to learn more about, I would encourage you to watch the video and review Mike's slides again, because we will not go deeper into that at this point. We will dive immediately into the challenges and experiences that you have faced in Iraq related to these issues. Okay, so Mike, if you are ready, you can go ahead and share your screen and present. You will have approximately 45 minutes or so. And I will stop you. I may stop you in between just to pause and take some questions, but then we will proceed. Okay?
Yeah, okay. Thank you very much, Marisol. Appreciate that. Thank you for the introduction. I'm just in the process of trying to share my screen. Let's have a look.
It's coming. It's coming online. Perfect.
Okay, Marisol. So you can confirm for me that you can see that first slide.
I can. It's now on full screen. Perfect.
Okay, super.
Thank you.
Thank you very much indeed for that introduction, Marisol. I have indeed been working in the environment, the oil and gas sector for quite some years now. I think probably over 3 decades. So I'm old, but not quite as old as Marisol alluded to. I was actually last in Iraq a couple of years ago when I was working with colleagues, and we conducted some field training in terms of how to remediate oil spills using bioremediation. And I think it was very successful. Maybe indeed one or two of you in the room may have attended. But I must say, I was very struck at the time by the level of commitment and the level of expertise displayed by our Iraqi colleagues working under difficult circumstances. So I have very fond memories of the last time I was in Iraq working on oil-related issues. As Marisol mentioned, by way of a quick introduction, I am leading UNEP's activities in Nigeria, specifically in the Niger Delta in Ogoniland, where we're actually working on arguably the world's largest terrestrial oil spill cleanup activities. In that part of Nigeria, Ogoniland, we have several hundred, if not thousands, of oil spills. The big ones originally related to, let's say, operator failure, whereby pipelines maybe have ruptured because they haven't been properly maintained, and 2 or 3 very large operational spills. But more latterly, more recently, the vast majority of spills, in excess of 90%, are as a result of criminal activities, predominantly stealing the oil so that they can refine the oil themselves and sell the oil to both the Nigerian market and the international oil market. So it's a vast criminal undertaking, and the environmental and public health consequences are extremely large, are profound, and of very serious consequence. Now, I will run through these slides, but as Maricel has mentioned, I think you're probably, or some of you are familiar with the content already, so I'll be quite quick, I'll be quite superficial, and I think really the key activity for us is, at the end of the presentation, if you, the audience, have any questions or any topics that you would like to explore in greater detail. Again, I apologize for my Anglo-Saxon accent, and if I'm speaking too fast, and I would request that the interpreters bring it to my attention if I'm running ahead of them and if they would like me to slow down or indeed recap on any point. So we'll run through an overview, setting the scene. We'll talk about the use of chemicals, management of wastes, and then we'll just do a quick recap of what the key learning points are. So in terms of setting the scene, 2016, something in the order of 96 million barrels of oil were produced each day. That equates to something like 2 liters per person on the planet. Oil and gas exploration is expected to invest around 700 billion a year up until 2040 to help meet global energy demands. And indeed, 3/4 of this activity happens in non-OPEC countries. 2017 report by the International Petroleum and Industry Environmental Conservation Association, or IPECA, and the International Finance Corporation, IFC, projected the following in terms of today's energy requirements and future energy requirements. That as of today, something in the order of 575 exajoules is the requirement, and this is serving in excess of 6 billion people. And as of today, oil and gas makes up about 52% of the energy demand. Projecting forward to 2035, the demand is estimated to grow to something like 720 exajoules, serving an audience of in excess or close to 9 billion people. And the interesting figure there for me is we're projecting through to 2035, yet the oil and gas portion of the energy demand is still in the order of 49%. So the reality of that scenario is that oil and gas and the challenges, the public health and the environmental challenges that go with the oil and gas sector is very much here to stay. And so we need to be planning for and strategizing in the long term how we address these problems, because the reality is, even with the advent of renewables, oil and gas is going to play a major part of the energy demand and energy sector for many years to come. In terms of the oil industry value chain, I think, as has been articulated already, but we're looking at upstream. So we're looking very much at the exploration and field development and production activities. Issues such as midstream and downstream are for other courses not being addressed in this present course. Okay, moving on for a quick discussion of the use of chemicals. We have here, as it were, the key stages of the oil and gas sector. Upstream, we've got from project concept through to geological evaluation and economic evaluation, exploration drilling, moving on to field management, actual production, and then the completion of that life cycle is well decommissioning, but that's many years down the road. So at many of these key stages, we are going to be using a host, a cocktail of different chemicals, many of which are toxic, hazardous in their nature. In terms of when are we using these chemicals, we're using them, as I say, at many different stages of the life cycle. We're using them for the initial drilling, for production. They're used in the pipelines, gas treatment, utility chemicals. They're added to assist with the flow, the export flow. They're added to track trace elements of hydrocarbons in water. And then there's also a stack of chemicals invariably stockpiled for use in emergencies as and when they're required. So a significant use of chemicals throughout the whole value chain. Now, I understand that we're talking today to many people with an environmental or a science or a chemistry background, so a lot of this would be well known to you. As I say, the objective of this is really just as a refresher, but it's going to be the properties of the chemicals which actually determine their fate and their impact in the environment. And very often, as environmental managers, we're going to need to know what it is we're dealing with. And are we talking about one or two chemicals, or are we talking about a composition of chemicals? And we need to also know the physical state. Are we talking about gas, liquid, or solid? Because that impacts upon the chemicals' mobility, transportation within the environment. Of primary interest to us in safeguarding the environment, safeguarding public health, is the chemical, or are the chemicals toxic? Are they toxic to humans or animals? And by animals, we're talking about fish, algae, crustacean, etc., present in the different environments in which we're operating. Are the chemicals biodegradable? The degree of their biodegradability will determine how long they persist in the environment, how long they take to break down. And are they bioaccumulative in terms of, if so, are they fat soluble, and will these chemicals then be mobilized and move through the food chain? Again, I hope that I'm not going too quickly, I'm not speaking too quickly, and if I were to be, then our colleagues who are translating will bring that to my attention.
You're perfect. It's perfect, Mike.
Okay. Thank you very much for that, Marisol. Okay, still talking about the characteristics of chemicals, there's a definition which we have to be familiar with, which is, are the chemicals harmful or are they hazardous? Now, harmful substances, harmful chemicals can have a negative adverse effect, but this will depend upon a number of factors, such as the amount of the chemical being discharged into the environment, the time, in other words, the duration, for how long is it being discharged, in what concentrations, and indeed, it's also a factor of the receiving environment. What is the nature of the environment into which those chemicals have been discharged? So that's harmful. Whereas hazardous, these are substances that may cause adverse effects as a result of its or their intrinsic properties, their level of toxicity, their ability to bioaccumulate. So there's a distinct change or distinct definition between that which is harmful and that which is hazardous. And again, when we're managing these chemicals, it's important for us to understand that difference. If we're talking about upstream activities in and around a drilling rig, drilling well, then there's going to be a large number of different waste products which are actually being discharged to the environment. We have drilled cuttings, which, as you probably know, are the rocks and the sand which are coming up from the well itself. The nature of the rock and the sand will be determined by the geology of the location. We have the drilling fluids, often referred to as drilling muds, and we have produced water. Produced water is liberated, and that water is often in close proximity association with the oil reserve itself. So as you liberate the oil, you're also liberating produced water. Now, it's those first three waste products, I would suggest, which invariably are going to represent the biggest waste management challenge to any upstream activity. So the big challenges are how to manage the cuttings, how to manage the spent fluids, after which they can't be recycled. They can be recycled a certain degree, but at the end of that, they lose their intrinsic properties and then become a waste product. And the produced water. These are really the big three. But obviously, we're going to be producing a lot of other waste, which we have to be mindful of. We're going to be producing drainage water, domestic water, such as grey water and black water from the residential areas on the rigs, whether they're offshore or onshore. There's a sewage, cooling water. We're going to be producing solid waste, such as municipal waste. And there will sadly be spills, and the spills themselves will be producing waste products. So as environmental managers, we have to strategize and we have to know how best to manage all of these different waste flows. So I've mentioned drilling fluids being a significant problem. And the first question arises for those who maybe aren't familiar, but what is a drilling fluid? Well, drilling fluids, they comprise a cocktail of chemicals. Some of them, as we'll go into a little bit more detail, are intrinsically toxic in nature. And drilling fluids are really what goes down the drill hole, the well hole, and the fluids there conduct a number of functions. They're to control the pressure, they're to keep the drilling head itself cool so it doesn't overheat, and it's also a means of transportation to bring the cuttings back up to the surface. Now, there are different types of drilling fluids, and they bring with them different challenges. Water-based drilling fluids, or the abbreviation WBDF, water-based drilling fluids, or oil-based drilling fluids, that's OBDF, which you'll often see written or referred to in the text. And then we have a third type of drilling fluids which have been developed more recently, and these are synthetic drilling fluids. And these have been developed to try and offset some of the environmental challenges associated with the oil-based drilling fluids. As I've mentioned, the drilling fluids really have the continuous face within the well, and all components are carried through that drilling fluid. Now, due to material costs and environmental concerns, the water-based fluids are always the ones which are considered first. They're the first port of call, they're the preferred option. As I say, from the oil company's point of view, they're advantageous because they're far cheaper, and also it improves their environmental performance. As I say, they're multifaceted, they complete a number of tasks, and as is shown by this schematic here, it's managing the pressure within the well, it's keeping the well cutting bits cooler, and then it's transporting back to the surface all of the cuttings. Drilling fluids have a long history. Back in the middle of the 1800s, typically it would be water, but water was only partially successful in as much as it couldn't often sustain the pressure and wasn't very good as a means of transportation, of moving the cuttings to the surface. Over this chart here, there's a period of evolution where clay was added to increase the thickness, to increase the viscosity of the fluids. Early 1900s, they started adding barytes to make the drilling fluid heavier and improve its carrying capacities, and also to control the pressure better. And then in the 1970s, that's when hydrocarbons in the form of diesel were added. But with growing environmental awareness in the 1970s, 1980s, these began to change, and in some locations to be banned because of the environmental impact associated with its use. Now, with water-based, primarily the predominant additive is, as the name suggests, water. They're typically used in simple wells where the pressure isn't too great. So very often the start of the well will be used with water-based drilling muds. And then as we go deeper and the pressures increase, that's when we have to switch to the oil-based or synthetic drilling muds. Very often water-based drilling fluids within Europe can be discharged to the environment, usually following some primary pre-treatment before discharged into the marine environment. We'll talk more about that. Within the water-based fluids, as you can see on the left-hand side of here, there's a cocktail of chemicals. There are salts and brines. There are often clays and viscosifiers. There's shale inhibitors. And it's quite often the shale inhibitors which we'll look at, which tend to be more problematic in terms of their toxicity. There are lubricants, corrosion inhibitors, biocides. Quite often the biocides can be problematic. So I won't go through them individually, but suffice to say, cocktail of chemicals are added to the water-based drilling fluids. Now, when we move on to the more problematic oil-based drilling fluids, again, as the name suggests, the base material is hydrocarbon, it's oil. Thus, when discharged into the environment, it has a consequence, it has an impact. And they're used in the deeper, more complicated wells. Often if we're doing horizontal drilling, that's when the oil-based muds will come in. But again, there are concerns because certain components are indeed toxic. And as a consequence, internationally, oil-based fluids are not allowed to be discharged into the marine environment and not allowed to be discharged on the terrestrial environment without treatment and disposal first before any residues can be, for example, landfilled. Again, another big list of additives similar to that which is added to the water-based, but again, the primary concern is the fact that it's a hydrocarbon matrix, which does have a significant environmental impact if and when discharged or indeed leaked. We've talked about the fact that water-based are actually cheaper because you're using water, not a hydrocarbon. They create a healthier working environment in terms of, in the working environment, there are fewer fumes given off. We don't have the hydrocarbon-related fumes which are being inhaled by the workers. Again, from an environmental point of view, they create less harm and create less complicated waste products. This is a photo here I think I took in Southeast Asia, maybe off of Borneo. But this is the seabed, and the image in the lower part shows where the water-based drilling muds have been discharged on the seabed. Very often done following pre-treatment, but has very little chemical effect on the environment. They're low in toxicity, but can have high pH, high salt content, which is quite rapidly dissipated within the marine environment. So the effect here, we see it's a physical effect, it's a smothering of the seabed, so harmful, but in this context, not hazardous. Oil-based drilling fluids, on the other hand, cannot be discharged. As we've discussed, they do result in severe environmental and health impacts if discharged in the marine environment, but indeed on the terrestrial environment. We've talked about many of the components being toxic, and if they leak into, for example, groundwater or surface water, then we have potentially a very serious public health risk. So they must be taken to treatment plants and they must be reclaimed, recycled, and then finally disposed of. Here's some figures quite recently from 2018 from the UK, and it just gives us a perspective. That year, 2018, water-based muds, something in the order of 16,000 tonnes were produced, of which only 7% were returned to shore for treatment, whereas 93% of the water-based muds were discharged at sea. Now that's in a tightly regulated environment, and the reason the majority is being discharged is that testing and protocols determine that there is no toxic effect within the marine environment and the risks are minimal. However, if you look at the next bullet point, the oil-based muds, almost double the amount of oil-based muds were produced, something in the order of 31,000 tonnes were produced in 2018 in the UK fields, of which 70% had to be returned to shore for treatment. 15% were treated thermally offshore at the point of generation, and only a small percentage, 15%, were re-injected into the well. So in fact, in totality, none of the oil-based muds were permitted to be discharged into the environment. 100% of them had to be reclaimed, treated, and then finally disposed of through one means or another. And just extrapolating, in the UK situation, this means that something in the order of 80 tonnes of cuttings are being produced per kilometre of drilled well. So that gives us an equation when we're planning for the future. If we know how many kilometres are going to be drilled, we can then extrapolate and know approximately how many tons of cuttings are going to be produced. We'll know in advance, are they toxic or not toxic, and we can plan accordingly for their handling and for their disposal. Now, we will share with you these slides. I won't go through them now, but I've also listed some references for you. These are specific to the handling, the management of drilling fluids. And once you get copies of these slides, you can follow up yourself as need be with this list of references. And indeed, there are many references which can be of help to you. Moving on to chemicals.
Mike?
Yes, Marisol.
Let me just pause here for a moment.
Sure.
So that then I know you're like ready to go full steam ahead. But let me just pause and ask if there are any clarification questions from the floor, from our participants. Because I know it's a lot. I mean, as Mike said, this is really a refresher presentation. It's an overview of the key issues that we need to think about. But we will not delve very much into detail because that has been covered in previous trainings before. So I just want to pause and in case that there are any clarification questions from the floor. Okay. I don't see any hands up or anyone speaking from the floor. Okay.
لا في سؤال. بالنسبة الأطيان الحفر ذات
For the drilling muds of the oil water-based, he says that 93% is discharged to the environment. What are the tests or the assessments that are made to for them to be discharged into the environment for the drilling muds, whether oil-based or water-based? Are there any mechanisms for treating them, for reusing them in case the treatment is costly and or is it possible or impossible to achieve these determinants required?
Mike, did you catch that?
I caught that, Marisol, yes, but I didn't catch a translation.
Oh. Uh-oh. Are you in the English channel?
Yes.
Okay. You have to select audio channel, and you should select English, not floor.
Okay, I believed I did that. To save me,
Okay, let me just repeat.
if you could just give me a thumbnail translation, Marisol, because I know you're multilingual.
Thanks to Interaxio. Let me try to rephrase. So the question was regarding the water-based drilling fluids and oil-based drilling fluids. Like, what are some of the testing procedures in order before they are discharged or sent out for treatment? What are the testing procedures involved, if you know? Let's say what they do in the offshore, what you presented in the UK's experience offshore, like what kind of testing do they undertake? And also then, like, is there any, like, in terms of the treatment, can they be recycled? Can some of these drilling fluids be recycled, recovered, and in terms of treatment? Although I know we will handle treatment later, but I'll allow you to respond to those two aspects.
Sure. Thank you very much for that. And I hope that our colleagues will, I do. In fact, I know our colleagues will be getting a translation of what I'm saying. Very good questions. In the oil industry, if we talk about Europe, the UK, and indeed North America, for example, it's a very mature industry, by which I mean, looking at some of the dates we were talking about, it's been around for over 100 years, and it tends to be a very regulated sector, by which I mean that it does have to comply with a lot of national and international regulations and guidelines. So the point being that when there's a proposal to do oil exploration activities, the companies that are licensed, part of that process is they have to produce their environmental and social impact assessments. They have to table a waste management plan. So the point being is there should be no surprises. There should be little, if anything, occurring which is not already anticipated at the planning stage. And the importance of that is that the environmental authorities know.
Mike, can you repeat that again? Can you repeat this again, this last part again?
It's going to be a combination of muds. It's going to be water-based for shallow drilling. It's going to move to oil-based or synthetic-based as we move deeper and as the pressure increases. So everything about these muds in a regulated environment should be known. The constituents, the chemical matrix, the environmental consequences, everything is documented and known. So the regulators are working from a position of information and of knowledge. Then once the activities are up and running, it's the regulator's responsibility to make sure the companies are complying with the plan, complying with the permits. And it will be to inspect them, to see what are they doing with the waste muds, how are they handling them, transporting them, and disposing of them. If we're talking, for example, a water-based drilling mud, then the environmental authorities would already have set their conditions of how that could be treated. And typically, a water-based drilling mud could, for example, go to different types of landfill, could be, for example, separated from the water content through use of centrifuging, what have you, and at the end of which, with a water-based mud, you should be ending up with a largely inert, non-toxic material, which could then go for landfill or backfill, or could be used in different ways. When we're talking about oil-based, then we said we've got a toxic matrix, and we already know, or should know, the composition. We already know those chemicals which are problematic in nature. And there will routinely be chemical tests done on the waste mud to confirm that it is indeed toxic and needs to be disposed of accordingly. So there would be some key parameters that we would look for. Heavy metals would be one, for example. But to the other part of your question is, because things like oil-based drilling fluids are extremely expensive, then you're very correct that due to financial considerations, these muds will be repeatedly reused. So typically, as the cuttings and the muds are coming up from the well itself, they'll be separated through going perhaps over shaker plates so that we're separating the cuttings and the solids to one side for treatment and disposal. And the muds themselves will go into holding tanks and will continually be recycled and reused until such time as their intrinsic properties, such as their weight and their ability to carry the cuttings, it's finite. It comes to a point where they can no longer be recycled, and at that point they cease to be a drilling mud and they become a waste product. And that's where the handling, transportation, treatment, and final disposal kicks in. So it's a long response to what was a very good question, but the answer is yes, there are particular chemicals of concern. We should know about them upfront in the planning and permitting stage. We can confirm their presence through laboratory testing, and then we can choose the appropriate disposal route. So let me go back to my colleague, and indeed perhaps Marisol would do some translation again for me and see if that answer satisfies our colleagues or if there's some more information required.
Thanks. Thank you, Mike. I mean, I know it was a very good question, but also like you can continue for the whole day, I think, answering that particular question.
Give me the opportunity, Marisol, and I will speak for the whole day.
I know. So, I mean, just to kind of just touch a little bit further on the testing part. I mean, is it correct to assume then, because the conditions of the process have been set based on the permitting process from the EIAs and permitting, then it is up to the operator to be testing their waste streams, correct? Before deciding what to do with it. Like there should be some testing systems in place in the field and operation itself.
Absolutely. Oil-based, drilling muds generally are so fundamental to the oil and gas sector that it's a very specialized skill. And the individuals who make the mud are called mudmen. And they're very, very well paid people coming from a typically chemical engineering type background. And they've got to get this mixture, this drilling fluid just right to cope with the very difficult conditions encountered down the borehole, down the wellhole. So it's a chemical matrix. They're constantly analyzing, checking, and indeed testing themselves for the chemical constituents. Those records have to be kept, and those records need to be made available to any government inspector who wishes to review them. So there's a very high onus on chemical analysis, chemical testing on the part of the operator, less so on the part of the regulator, who can do it at their discretion, but also, again, at the cost of the operator.
Thanks. And Mike, could you just give us a short answer in terms of why would an operator choose a water-based drilling fluid versus an oil-based drilling fluid, aside from the cost? You mentioned that cost is a consideration, but what are some of the decision points that they consider? Because if you look at it, if water-based drilling fluids were less toxic and has less adverse effects on the environment, why not use just water-based drilling fluids?
Yeah, absolutely. Absolutely. The oil companies would prefer to use water-based drilling fluids from the point of view they're far cheaper. So if it was down to cost alone, they would use water-based. But water-based isn't as effective in deep wells. The reason being, the deeper we go, the greater the pressure is. And then we get things like the wells themselves will collapse inwards if the drilling fluid can't sustain the pressure in the well. So at a given depth and at a given temperature and pressure, they will have to switch to they will have to switch from water-based to oil-based. And the reason being that the oil-based contains and manages the pressure better, it retains its structural integrity better, it has higher thickness viscosity, so it's also better at transporting the cuttings back up to the surface. So on cost alone, water-based is preferred. But when we get into technically challenging environments, then unfortunately it's always going to have to be a switch to either an oil-based or one of the new synthetic-based drilling chemicals. So it's really to manage those conditions which are found deeper down within the well itself.
Thank you very much, Mike. That was very clear. So I will ask Mike to now proceed with the rest of his presentation. And Mike, do you think, let's see if we can wrap up in about 15 minutes for the remaining part, and then we'll take another round of questions from the floor.
Absolutely, no problem at all. Okay, so we've talked about chemicals within the drilling fluids. That's a major area of use of chemicals and waste production. We have chemicals right the way through the chain of utility, the life cycle. So the next couple of slides about chemicals used for cementing. And sorry, is that a question coming through?
I'm just going to mute the floor, okay?
I'm just wondering if that's a question, Marisol, coming through.
Is there a question?
Just an organizational intervention, I think.
Jolly good. So we're talking about cementing of the well.
Wait, hold on, Mike. Hold on. Mike, just hang on.
Sure.
Mr. Youssef, is there something you want to say, or in terms of some organizing?
لا هو كان بس إجراء تنظيمي بخصوص يعني تقديم الأسئلة والمداخلات من داخل القاعة.
Regarding presenting questions and comments only. So if you have any comment or any question, please register or raise your hand.
Questions after the presentation of Mike. Okay? Okay? We will take more questions after Mike's presentation. Okay, so Mike, please proceed.
تفضل مايك. شكرا. السيمنتيشن أو غلقي البئر بالأسمنت بعد sorry again, switched.
All right, thank you. Okay, Mike, please go ahead.
Are you sure, Marisol?
Yes. Third time. Please
Here
go
we
ahead.
go. Here we go. Okay, so there's cementing chemicals are used. These are to fix the well and seal the well once that it's actually been drilled. Again, a cocktail of chemicals used within the cement itself, dispersants and surfactants, retarders, polymers. We don't need to go into them in detail other than to understand that there's a range of different chemicals within the cementing products for a range of different activities and requirements that are used. Then when the well is completed, again, there's another tranche, another round of chemical adhesives, which is making the drilling well ready for production. This stage is only completed if the well is economically viable, if the reservoir is such that it makes it feasible to exploit it. We have the completion chemicals. These, again, they retain long-term the structural integrity of the well. They prevent the ingress of formation fluids so that we don't get too much mixing of the hydrocarbons and other fluids, help to keep the well clean and functional, and within which we're putting the production tubing and the downhole tools. Then we have, moving on, the completion chemicals. They help to clean the well. There's a number of active agents introduced into the well, and lots of polymers, again, other chemicals. But all of this has to be well documented at the stage of the EIA, at the stage of the planning access. So the regulators, the environmental enforcers, all of this has to be known upfront in advance. Many different chemicals are used for wash chemicals, for cleaning the rigs. Thick greases are used on the drill strings, for example. We've got a blowout preventer fluid. These are used on and around the valves, hydraulic fluids. So similar to any industrial setting, as it were, a range of lubricants, hydrocarbons, and fluids. Again, many of which are hazardous when discharged into the environment. In terms of the production process, we've got different phases involved in transporting the oil and gas from the wellhead itself to the stabilized marketable products. And the production chemicals really are to help manage the different phases in the products that we've got. We've got oil, we have water, we have gas, many chemicals added to help manage and separate and transport those different products. Again, a range of chemicals, I won't dwell on those. Now, in production chemicals, everything that is added is ultimately going to be discharged into the environment one way or another. And when we're looking at chemicals, then we're going to look at what's their environmental risk. And these internationally are color-coded, and we'll go on to talk about that later. And it's a simple traffic light system where if it's green, it's not of concern. If it's yellow or orange, it's of minor concern. Where we have red listed chemicals, then we know that we have areas of environmental and public health concern that we have to keep a close eye on. Again, when you're managing chemicals, I've listed here some references for you. Again, there's no shortage of references. Some of them are very informative and will give you a lot of background information, will give you how you monitor, regulate, and indeed manage these chemicals. Many of these documents are put together through organizations such as the World Bank, the European Commission, the International Organization of Oil and Gas Producers. So there's a wealth of good technical literature out there should you need further reference. Produced water, this is another one of our very significant waste management problems. The produced water, as I mentioned, is water often in association with the hydrocarbons below ground. When we liberate the hydrocarbons, then we always liberate produced water. It's a question of how much and what chemical constituents are in the produced water. There's a range of chemicals. Typically, there's going to be inorganic salts. There's going to be some of the BTECs, the benzene, toluene, ethylene, and xylene, which are of concern to us. Polyaromatic hydrocarbons, heavy metals. So to determine what you can do with the produced water, then you have to have an understanding of the chemical composition. And out on the rigs, again, it's the operator's responsibility to be doing this sort of chemical analysis and keeping records available for the regulators to actually review. Now, discharging of the produced water can be problematic. If we're talking in a marine environment, then it can introduce long-term effects. The concern for public health is some of the constituents can be hormone interfering, mutagenic, reprotoxic effects. So suffice to say, they fall under this red list of chemicals which we have to be concerned about. How we manage the discharge of produced water, again, it's a nature of the environment. Where is it occurring? If it's happening out at sea, if it's happening on land, we need to know how much produced water. We need to know the chemical composition. And we've got to look at the quality of the receiving environment, the environment's ability to absorb what is being discharged. And for example, I talked about the United Kingdom. Most of our oil activities are offshore in the North Sea. Early on, perhaps in the 70s, in the 80s, most produced water was allowed to be discharged into the marine environment. It took some years to realize that the produced water was actually contributing majorly to offshore pollution within the North Sea. So requirements, restrictions have been very much tightened up in more recent years. Again, produced water, here's a list of references for you should you need in the execution of your duties to look at these in more detail. There's a number of references here on produced water. Now, getting on to legislation, and this will be a very simplistic overview because we are having a number of presentations in more detail on a number of these international legislations. But within the country of operation, in this instance, obviously, Iraq, But typically, you'll have a combination of national legislation and guidelines which are derived from or are mirrored in international legislation, international conventions. So the national legislation should harmonize itself with international best practice, international legislation. Looking at the UK, for example, we have COSH, which is Control of Substances Hazardous to Health Regulations. That tells us the chemicals of concern, how they need to be handled, the protective personal equipment that needs to be used, how to be disposed of. We've got health and safety regulations, which focus very much on the potential impacts on human health, public health, and the safety requirements needed to be employed by the operators. Then we move into some European type legislation. We've got CLP, classification, labeling, and packaging of substance mixtures regulations. We've got the UN legislation here, which is the GHS, the globally harmonized system. We've got CHIP, chemicals, hazardous information and packaging for supply amendment regulations. And finally, we've got their REACH, registration, evaluation, authorization, restriction of chemicals. So there's a whole host of both national and international guidelines and legislation. And the idea being that national legislation will reflect and will harmonize with this international guidelines, international regulations. And we're going to talk in some more detail about some of the most important international guidelines and practices in other presentations to follow. I mentioned earlier that we have a way of color coding, traffic lighting the chemicals to easily and clearly communicate the perceived risk or the potential risk. And these are in compliance with both the CLP and the United Nations Globally Harmonized System, the GHS. So again, quite straightforward, quite obvious, the idea being that internationally, irrespective of language, is to communicate to the users the potential risk, raise awareness, raise understandings of preventative measures, health and safety, personal protective equipment. Now, when we're managing chemicals, I would suggest that the most important tool at our disposal is what's known as the MSDS. That is the Material Safety Data Sheet. Now, the MSDS has to, by international regulations, has to accompany every chemical which is transported, shipped, and used within the workplace. And these are of fundamental importance because all the information you will need as the operator or as the regulator, all the information you'll need is simplified on the MSDS. It tells us what are the risks, what are the hazards. It tells us about health and safety, personal protective equipment. In the event of an accident, it tells you what the first aid procedures are. So this really is the starting point of the management of chemicals. As a regulator, you're going to be looking to see in the workplace, do the staff have access to the material safety data sheet? Is it up on the wall? Is it legible? Is it in good condition? Alternatively, is it accessible electronically via a computer system? The onus is on the operator, the employer, to make sure the MSDS is available and that all staff are trained in the MSDS is specific to the chemicals that they are encountering. Now, I'll pause for breath. I know some of these concepts are a little bit complicated, maybe not so easily translated, but again, if there's any challenges, anything that you want me to reiterate, then do please let me know and I'm very happy to do so. Within the point of production or the point of exploration, then we're also making a number of emissions to air. The COx, the NOx, the SOx, for example, carbon-based, nitrogen-based, sulfur-based discharges. These need to be strictly regulated. They need to be contained and in compliance again with national international guidelines. Those of concerns would, for example, be the VOCs, the volatile organic components, but also the PAHs, and I'm glad at this point I'm not a translator, polyaromatic hydrocarbons. And these are contributing or do contribute in the local environment to problems such as acid rain, acidification of water, problems to public health when inhaled, but also the global phenomenon of climate change. These sorts of emissions to air are contributing to global warming and are coming under, as it were, the microscope and stricter legislation all around the globe. A small waste product that we need to be mindful of is NORM, which stands for Naturally Occurring Radioactive Materials. The acronym is NORM. And this relates to materials, quite often cuttings from the underlying geology, which could be radioactive in nature. And this is a phenomenon where the underlying geology, the underlying rocks and sediments have a degree of radioactive material in them. And the actual oil exploration production process is, as it were, accumulating these materials and getting them to a level where they can potentially trigger radioactive alarms, radiation alarms. And the disposal facilities need to be aware, those handling the waste need to be aware, and there are particular procedures which need to be put in place. And examples of where this NORM waste could come from could, for example, be uranium, thorium, potassium, radium, all of which can be naturally occurring in the rocks. So it's typically not a large waste management problem, but it's a problem we need to be thinking of. And are we likely to encounter this problem? And if so, what measures need to be put in place? A quick discussion now on the management of upstream waste. We've talked about the main waste problems being, for example, produced water, drilling muds, cuttings, and chemicals. And there's a range of waste management options that we need to be mindful of. We know in terms of waste definition that waste is something, a subject or an object which no longer has value. It's being discarded. All forms of waste must be managed to control the environmental problem, and we need to minimize the amount of waste being generated. And that is true also for the oil and gas sector. There's a problem in the waste management sector, often of identifying what is waste and what is not a waste. A product is not a waste if it's destined for recycling, if there's a recycling market, if this particular material can be used and there is a market for it. So an example there is drilling fluid, which has gone through the drill bits and come out and is in the drill fluid holding tank. It's not at that stage a waste because it's going to be reused. When it can no longer be reused, that's when it actually becomes a waste. Now, the wastes that we're of particular interest are hazardous waste, hazardous by their toxic nature. And these wastes, if not properly managed, will have a profound, significant effect on environment and public health. And they must be strictly controlled, regulated, and monitored. A point there is if an international oil company is operating in a different country, in a developing country, for example, if the company is European, British, American, they cannot lower their operating standards. They cannot lower their environmental performance to mirror the national legislation. They always have to operate in compliance with best international practice from Europe, North America, the UK, for example. They cannot lower their standards simply because they're in an environment where perhaps the environmental legislation and enforcement is not as stringent. Hazardous waste cannot be routinely disposed of along with municipal waste and other inert waste. They have to go to state-of-the-art hazardous waste disposal facilities. A quick look at this chart here is we can see this is just indicative of the types of hazardous waste being produced and typically their disposal routes. And if we look here at the bottom of the chart, green is waste containing oil, and we can see that it's a significant proportion of the hazardous waste sector and continuing to grow, although we saw a slight plateauing off some years back, but it's still a major hazardous waste concern. There are many different properties which make waste hazardous in nature. And these are the international symbols used, should be affixed to the packaging of the products. And wastes are hazardous for a number of considerations, such as, are they flammable? Are they an irritant? Are they oxidizing? Do they present problems with acute toxicity? And these international symbols will communicate to the user and the handler and the disposer what are the particular risks associated with this waste product. As I've said, hazardous waste cannot be mixed, it cannot be diluted, it can only be disposed of by licensed contractors at approved and permitted facilities. So that's my very fast run through the sorts of chemicals which we can be using in the sector, the sort of waste products which can be used, or which rather will be generated, and how we're going to manage and how we're going to handle those sorts of wastes. So in terms of the key learning points, as it were, from this quite rapid presentation is oil and gas. This sector is here to stay for the foreseeable future, as are the environmental, public health and waste management challenges that go with it. So we need to be planning for the long term. The oil and gas sector is a very large producer of chemicals and a very significant producer of wastes, in particular hazardous wastes. Many of the chemicals which are being used and many of the chemical byproducts are hazardous in nature, require particular handling, transportation, and ultimately disposal. The biggest problems we need to be mindful of are things like drilling fluids, produced water, and indeed cuttings which are liberated from the drill itself. We need to understand the difference between when is a waste or when is a product a waste and when is it not a waste. If it's at the point of recycling, for recycling, at that stage it's not a waste. And when we're talking about hazardous waste, we need to be mindful of it cannot be mixed, it cannot be diluted, and it must be treated at specialized, permitted facilities. Thank you. That's my rapid run through. Marisol, I'll hand it back to you.
Thanks.
Thank you very much.
Thank you very much, Mike. I have to give you a round of applause because
thank you.
For those of you who may not know, we normally have a 4-day training on this very topic on these slides that Mike is showing. So it's a bit unfair to ask Mike to present it in an hour's time, but I think you've done fantastic, Mike, for condensing that. But so let me pause. You can stop sharing your screen, Mike, so I still see your screen. Let me then open up the floor to some other clarification questions. Actually, maybe Mike, keep your slides open just in case we need to make reference to them.
Okay. Are you actually seeing them now, Marisol?
I don't see your slides. I see your desktop. So you have to kind of open up your presentation.
Okay. Let's go back into that. Having just shut it down, let me open it up again.
Yeah. So meanwhile, are there any questions from the floor? And when you're asking your question, just please remind us who you are, introduce yourself and your institution. Okay, so we can just have an idea who's speaking and get to know you a bit better. So are there any clarification questions from the floor?
بالنسبة لآلية التعامل مع
As for the mechanism of dealing with wastes of the drilling mud, and sorry, the dealing with these wastes before getting rid of it completely. Oh, final disposal.
I don't understand. I didn't get the question.
نعم.
I'm sorry, the masks prevent me from hearing. So mechanism of dealing with the wastes in the last slide, in dealing with wastes, we asked first about the drilling muds. Now we're talking about the dealing with the wastes. So if there are a treatment, preliminary treatment to reach the final discharge. So is there a mechanism to reuse in a way not to affect the environment?
I'm not sure if I understand the full question, Mike, but I think it's back to let's say if we envision being on the operator's field, and they have these wastes, like what is the on-site treatment procedures there, if any, if there can be any, before then they are finally disposed of in final treatment areas.
Okay, thank you, Marisol. You're still hearing me okay?
I can, yes.
Okay, super. Yeah, well, we're working in two distinct environments globally, offshore and onshore. Now, typically at the work site, there is little, if any, treatment of waste being done. Offshore, primarily because of the absence of space. Onshore, we've got the luxury of space, but more typically, the correct procedures within the working environment is waste have to be clearly segregated. So whatever the waste products are, if we're talking about cuttings, if we're talking about muds, they're going to be segregated. If we have a waste mud that has the drilling fluid and the cuttings, some of the pre-treatment on site could, for example, be going over shaker screens to separate the liquid from the solid. Then thereafter, the fluids would be held in a tank or a lined pit. The cuttings themselves, depending if they're water-based or oil-based, could either then go for reuse, because if it's from a water-based product, then they're not going to be toxic and they can be used as a backfill material or a cover material. If they're coming from oil-based mud, typically then they're still going to need to be disposed of within a hazardous waste treatment facility. If we're talking waste chemicals, they need to be segregated at the work site. They need to be properly contained. They need to be labeled and put to one side safely, awaiting collection and transportation. So generally, there's minimal waste treatment done at the work site. Predominantly, it's more waste identification, some pre-treatment, segregation. They're the key steps really within the work site.
Okay. I hope that answers some of your questions. We will actually have Mike has a presentation tomorrow on treatment, different treatment options. So we will go in greater detail on treatment of waste tomorrow. So we can come back to some of these questions. Are there any other clarification questions before we go on break, on a coffee tea break? Are there any questions from the floor?
نعم نعم رئيس مهندسين باسمة فاضل.
Yes, I am a head technician. I monitor the chemical material, and working in this, I felt that the MDS mentions the. Can I please ask her to slow down? She's speaking very quickly.
SDS.
Oh, okay, hold on. Can we ask you to speak slowly because we're not getting the full
من خلال العمل
interpretation.
في مجال مراقبة.
Through working in monitoring the chemical materials and importing them through the oil companies, they were added the MSDS and the physical and chemical characteristics and their effect and the irritant aspects, but they did not mention the changes that happen to this material as we import these materials. So is MSDS an approved document? Because more than MSDS can be taken electronically, could be irritant, could be mentioned as toxic. So in other sites, other websites could be different description. So is this document approved internationally? I hope you understand the question. She was still speaking very quickly. I'm sorry.
Mike, did you catch a bit? Did you catch that?
I'm afraid I didn't, Marisol. I'd need
Okay.
you just to give me a thumbnail translation.
Okay, so it's regarding the MSDS. And so the question is, sometimes there are changes in the nature of the specific chemicals that the MSDS is referring to, but then that's not really captured in the MSDS sheet. So that's one aspect of the first part of the question, and then I think the other the other part of the question was, is MSDS accepted, recognized internationally?
Okay, thank you, Marisol. Yeah, if I take the second part first, absolutely. If we're working to best international practice, MSDS absolutely, fundamentally, they must be used, they must be displayed at the work site. Staff have to be trained in the MSDS by the employer, and it is the employer's legal responsibility to do this, and it's the employer, or let's say the operator's legal responsibility to regularly update the MSDSs. So if there's an update and the operator, the employer, it's their legal responsibility to keep on top of changes, of modifications within the MSDS, and to be displaying the most up-to-date MSDS. If there was an accident and if staff were to become, let's say, injured, the operator would be found to be negligent if he didn't have the most up-to-date MSDS. And in addition to which, there's a training responsibility regarding the MSDS. So, for example, an operator, if they are using, let's say, staff from Southeast Asia, whose English, written English, reading, the level of reading of English isn't strong, that's not a defense for the operator either. The operator must train the workers to the level that they are competent and they understand. And